Okay, this is the solution for number 2. Letter B, example 26b. So as you can see here, let's try to solve example 26b. So let's go now to our open board, and then let's have a new page. Okay, not this one. Yes, I think this one here. Let's have a new page. Okay, this one here. Example 26 solution for example 26 letter B. So let's copy first the given. The given is a sub n is equal to 5 5 a sub n minus 1 minus 6 a sub n minus 2 for n greater than 1 with a sub 0 is equal to 0 and a sub 1 is equal to 1. Okay, so this is the solution for example 26b. So you have noticed this is a linear recurrence relation of order 2. Okay, so our k is 2. So our a sub n is expressed using two previous values, a sub n minus 1 and a sub n minus 2. So just like in the previous solution for letter A, let's assume that our a of x is equal to summation of a sub n x to the n, where n starts from 0 to positive infinity. Okay, then just like in our previous example, if you notice, okay, first step is to multiply by x to the n and then sum, and then evaluate the sums, then solve the equation to derive an explicit formula, and then express the OGF as a power series. Okay, so we will try EGF later, maybe in the last example. So that's how you are going to use this step. So F2, okay, so copy just like before. I don't know if you notice the given here is starts a sub n, not a sub n plus 1. Okay, so I think this is much easier maybe. So let's copy a sub n is equal to 5 a sub n minus 1 minus 6 a sub n minus 2, and then multiply both sides by x to the n. Okay, 5 a sub n minus 1 plus 2 x to the n, and then distribute a sub n x to the n. We have 5 a sub n minus 1 x to the n minus 6 a sub n minus 2 x to the n. Okay, and then get the sum. So we have here summation of a sub n, x to the n. So n starts from, guess what should we do? 5 a sub n. Is it 0? We'll start at n is equal to 0. What will you do? Or do you have a guess? So before moving forward, maybe you can try it at home, in your respective home. So what should we do here? N starts from 0, from 1, or what should we do? Okay, so remember that our given start with 2. So let's try this method. Let's start with 2. Okay, and then let's distribute our summation. 5 a sub n minus 1 x to the n minus 6 summation of a sub n minus 2 x to the n, and starts from 2 to positive infinity, 2 to positive infinity, a sub n x to the n, and starts from 2 to positive infinity. Okay, or maybe you have a method before. Okay, maybe you will start at n is equal to 0. It depends upon you. Okay, or let's start with 0. Okay, but try it if you will start with 2 at home. Okay, so what will be the result? So this will be exciting. I don't know what's in your mind, so let's start with 0. Okay, so okay, so the what is the value for the right hand side? No, the left hand side, this one here. This is what? This is a of x. I don't know if you get the answer, because we let this one before. I guess they are the same, this one here, but we have here a shift. Okay, we have here a shift from left or right. Let's go back to our, where are you, this ordinary, this one here, right shift, a sub n minus 1, n starts from 1, n starts from 1 here. Okay, this is from 1. So remember to use this formula. Okay, so let's go to our open board. So from the table we have we have 5, n is equal to, no, not 0. Okay, what happened here? Do we have a problem? Is it okay if we start with n is equal to 0? I think, what do you think? I think it will not work. It will not work. Why? Because when n is equal to 0, as you can see here, we have a sub negative 1. Okay? And we don't have a term which is a sub negative 1. Okay? So it will not work. So I guess let's erase this one here. Okay? Let's replace this with 2, not 1. Okay? Not 1. Because if we start with 1, there will be a problem in the second term, this one here. We have a sub negative 1 if we start with 1. So we will start with 2. Okay? So since our goal is to write it in this form, our n starts with 0, let's add. So what we'll do here is we add 2 more terms, a sub 0 x to the 0 plus a sub 1 x plus summation of a sub n x to the n starts from 2 to positive infinity, so that the left hand side will become a of x. Okay, this will become a of x. This is our a of x. This will become summation of that's getting uglier. Let's try this one here. A sub n x to the n starts from 0 to positive infinity. So if you expand the left hand side, a sub 0 x to the 0, we have this one. When it's equal to 1, we have this one here, x to the 1. And then when it's equal to 2, we have this one here. Okay? How about this expression here? This one. So how do we solve this expression here? Okay, how do we solve it? How can we write it in the form a of x, this one here? Okay, so I guess I don't know if you get it already. You can write it. So maybe we can put this one here. Oops. Can put 5 here. And also our 6 somewhere here first. Okay, they're just the same. So if we add a sub 0, a sub 0, okay, a sub 0, 5 a sub, we have 5 a sub 0 plus 5 a sub 1 x plus summation of 5 a sub n minus 1 x to the n starts from 2 to positive infinity. And you will do it the same here. Let's put a parenthesis. A sub 0 6, okay, sorry, should be 6 a sub 0 x to the 0 plus 6 a sub 1 x to the 1 plus summation of 5 6a sub n minus 2 uh, 0 1 2 x to the n starts from 2 to positive infinity. Okay. Okay, please do remember that this will become this one here. This will become summation. Notice that we add. Okay, remember that we add both sides. We add a sub 0 here and a sub 1, so therefore we have to add also somewhere here. Okay, we add plus a sub 0 and a sub 1 x. Okay, that way. Okay, so and then please do remember that let's erase this one here first. Okay, so what will happen here is okay, so don't forget, since we add these two terms here, we have to subtract somewhere. Okay, somewhere here. If you transpose a sub 0 and a sub 1, we have 0. Okay, so I think I made a mistake somewhere here. I think I should not add this term here and this one also. Maybe it's getting messy, so I think I made a mistake somewhere. I should not write this one here, this one, and also this one here. So let's erase. Okay, let's erase it completely. I think I made a mistake. Okay, so let's erase this one. This one here. Okay, so this is correct. Okay, that one is correct, but the first term on the right hand side, this should be summation of just copy 5 a sub n minus 1 x to the n minus summation of where are you, summation of 6 sorry for that one, 6 a sub n minus 2 x to the n starts from 2 to positive infinity, n is equal to 2 to positive infinity. Notice that this is 5 x a of xy. Why is it? It's notice that let me explain it here somewhere in the scratch paper. Let's have here scratch paper. Let's try this color scratch paper. Okay, notice that if you have summation of 5 a sub n minus 1 x to the n, n is equal to 2 to positive infinity, just use where are you, this one here, this one here. Okay, this one, yeah, right shift. Okay, if you expand this one, this is equal to what do you call this one, 5x ax. Okay, why is that? if you will expand the right hand side, we have 5a sub 1 x squared, okay, x squared plus 5a sub 2 x cubed plus n starts at 2, uh, 5a sub 3 x cubed, and so on, so forth. But the left hand side is, we know that this is 5x, uh, a of x is a sub 0 plus a sub 1x plus a sub 2x squared, and so on and so forth. So are they equal? Okay, so if you distribute, we know that a sub 0 is 0. Okay, so this will become 5, distribute here, so on and so forth. So this become 5 a sub 1 x squared plus 5 a sub 2 x cubed, and so on and so forth. Okay, which is equal to the right hand side, this one here. Okay, they are just equal. Okay, just compare. Okay, so that's the reason why you have here 5x a to the x. The same analogy if you are going to expand the, what they call this one, the second term. This is minus 6 x squared, a of x. Okay, minus since we add this thing here, this one here, so we add also somewhere, we have a sub 0 plus a sub 1 x, and we know that a sub 0 is equal to 0 and a sub 1 is equal to 1, so what remains here is plus x. So for the second term, this is now our a of x is equal to 5x a of x. So before I'm going to show you the second term on the right hand side, this one here. Let's remember second term. Let's try the second term. We have 6 summation of a sub n minus 2 x to the n, and starts from 2 to positive infinity, and we argue that this is equal to x squared, 6x squared ax, this one here. Okay, so this is 6 x squared a of x. So are they equal? Okay, so if you try to expand, so this is 6 a sub 0 and starts at 2 x squared plus 6a sub 1 x cubed plus 6a sub 2 x to the 4, and so on. Okay, how about the left hand side? Okay, so left hand side we have 6x squared, we have a sub 0 plus a sub 1 x plus a sub 2 x squared plus dot dot dot. Okay, if you try to substitute, we know that this is 0 and this is a sub 0. Did I make a mistake somewhere? 6x squared. No, we will not, sorry, just substitute that one here. So this will become 6x squared, 6 a sub 0 x squared, okay, plus 6a sub 1 x cubed plus 6a sub 2 x to the 4, okay, is equal to the right hand side. So they are equal. So I don't know if you notice, we have here that one. I guess they are equal. Okay, there's a lot of mosquitoes here. Okay, plus that. Okay, they are equal, and so on and so forth. Okay, so that's it for the second term. Okay, so we can simplify now. We can factor out. This is a of x. Let's move a of x to all terms that has a of x to the left hand side, minus 5x a of x plus 6x squared a of x is equal to x. Okay, and then let's factor out a of x, 1 minus 5x plus 6x squared is equal to x. So our a of x is equal to x over 1 minus 5x plus 6x squared. Okay, and if you want to factor out, you can write it in this form. A of x is equal to, factor out the denominator. So I guess we can write this in this form here. We have 1, 1, we have minus. Let's try 3x here and 2x. So first term 1 times 1, middle term negative 3, negative 2, we have negative 5, negative 3 times negative 2, we have positive 6x squared. So using partial fraction, I will not show it here, just do it at home. Okay, this is a of x is equal to x, no, not that one. This is equal to x times 1 over 1 minus 3x minus 1 over 1 minus 2x. I think I have to rewrite this one. Sorry. So let's try this one. X. Okay, that's the generating function. So from here you have use partial fraction. Okay, so I guess we can now apply the power series for what do you call this one, geometric series. Okay, so we can apply it here. So okay, since I think since we made a shortcut, I think I made a mistake here. When I recall my notes, it should be this one. Okay, that one. Okay, so that's the answer. So all you have to do is I'm sorry, I made a mistake. Okay, so that is the when you use partial fraction, this expression here is equal to this one. Okay, so uh, the scratch paper here, scratch paper. So you just write x over 1 minus 3x, uh, 1 minus 2x is equal to, let's say we use a, we have b plus c over 1 minus 3x. This is 1 minus 2x, and notice that this is linear, so multiply both sides by 1 minus 3x and 1 minus 2x. We have b 1 minus 2x plus c 1 minus 3x, and then just continue and you will arrive at uh, this one here. Okay, so recall that this implies that 1 minus 3x 1 over 1 minus 3x minus 1 over 1 minus 2x, if we use our power series, geometric power series, in the recall, I don't know if you remember, let's say somewhere here, recall that 1 over 1 minus x is equal to summation of x to the n starts from 0 to positive infinity. So this is summation, this is summation of uh, 3x to the n starts from 0 to positive infinity, minus summation of 2x raised to the power of n starts from 0 to positive infinity. And we are almost done. This is summation of 3 to the n x to the n minus summation of 2 to the n x to the n, and starts from 0 to positive infinity, and starts from 0 to positive infinity, and combine we have 3 to the n minus 2 to the n x to the n, and starts from 0 to positive infinity. So this implies that an is equal to 3 to the n minus 2 to the n. Okay, but as I've said, our given where are you? Our given is in terms of this one, a of n, so we will not write it as a sub n plus 1. So this is the final answer. Okay, so that's the final answer. And if you compare, if you want to verify using your if you want to verify verification using our given and using the closed form, a sub n is equal to 3 to the n minus 2 to the n. Our given is, where are you, 5, okay, n greater than 1. sub 0, a sub n 5, a sub n minus 1 minus 6, a sub n minus 2 for n greater than 1, with a sub 0 is equal to 0 and a sub 1 is equal to 1. Okay, so if you want to verify, am I right? Sub 0, okay, and minus 2. So let's try with n is equal to 2. So a sub 2 is equal to 5, a sub 1 minus 6 a sub 0. So this is 5, a sub 1 is 1, minus 6, a sub 0 is 0. So the answer is 5. How about for the closed form? So we have n is equal to 2, a sub 2 is equal to 3 square minus 2 square is equal to 9 minus 4, and this is 5. Okay, they are equal. Let's try more. Maybe this is the last one. A sub 3, we have 5, a sub 2 minus 6, a sub 1. Okay, this is a sub 2 is 5 minus 6, a sub 1 is 1. So this is 25 minus 6, 19, right? 19. How about yes sir, sige sir. A sub 3, we have 3 to the 3 minus 2 to the 3. This is 27 minus 8. What is 27 minus 8? This is 19, and they are equal. So you can extend it more if you don't believe me. This is the closed form. Okay, so just like before, if you want to get the order, so it will be easier if you use the what do you call this one, this our formula to get the order of the convergence. Okay, if it is quadratic or linear convergence, since we already have a closed form expression of our p sub n plus 1 or a sub n plus 1, then you can easily get the limit. Okay, so I'm going to ask this in the EdPaso for all those what do you call this one, given in example 26. Okay, so just do it at home, and just remember what I have discussed in this area here. So that's it for now. I guess I've explained it to you well. I don't know if you understand, but generating functions are very nice tool to find the closed form of the given recurrence relation. So try it at home for maybe for this given for C, and for D if you want. For E, I think we will not solve C and D. Okay, maybe I can show you letter E, since I will be using exponential generating function. Okay, for letter E. I don't know if C and D. I think you can use OGF for C and D. Okay, just try it at home, or maybe I will put this one as a problem set or assignment. Okay, and also to get the order of convergence, to find C, and so on and so forth. Okay, so I guess this is the last no, not the last, but I'm going to show you the solution for letter E. I've decided, I'm sorry, that I've said that I'm going to show you to solve all the examples, all in example 26 from A to E, but then I realized that I think this will be easy. Okay, easy to to get the closed form. Okay, so that's it. So wait for solution for example 26, letter E. God bless everyone.